electric potential that involves differentiation. Now, this is the part 2 of the video. In the part 1, we introduce electric potential, calculation involving it. Now, this is the part 2 on the electric potential. We want to focus on electric potential that will take you to differentiation, that involves differentiation. Now, let's say you have, given that you have electric potential to be X, Y, and Z. Now, and they ask you to calculate the electric potential. Now, you have to calculate it using both the X and the Y and the Z coordinate. What am I saying? You can see from the board I said EX is equals to dV, which is the electric the potential all over dx. Now, if you want to differentiate, I'm not here to teach differentiation. I'm just here to introduce this topic and do the calculation under it. Now, if you have problem with differentiation, check my channel to know how to differentiate. Now, this is the V all over dx. What it means is negative. Remember, there's minus here, minus here, minus here. Now, what this thing means is the negative derivative of V with respect to x. If I give you the x all over the y, what it means is the derivative of x with respect to y. Now, this is the v all over dx. So, this is the derivative of the v with respect to x. Now, what it means is whatever quantity here, you are keeping both x and both y and z constant. Now, look at here, the v all over the y. It means this is the only thing we want to differentiate. Any other thing, we are not seeing it. That is why I said that is negative derivative of v with respect to y, keeping s and z constant. The same thing is happening here. You're only differentiating with respect to z. It means whenever you see z, that's where you differentiate. Any other quantity, you are not seeing it. So that is what this means. Let me. Now, the electric potential function at a point V is given as this. Find the electric field at that point. There is one thing I did not mention at the start of this video, that if you are being given electric potential and you are asked to calculate the electric field at that point, what you have to do is you differentiate the electric potential at that point with respect to s, y, and z, and at the end you add everything together. This is what I'm going to do here. Now remember, I already wrote the formula. Es is differentiating with respect to x. So this is the v. So if I want to differentiate this with respect to s, I'm only interested in the quantity that have x. Now, if I differentiate 2xy, the answer here, remember we have minus here, the answer here is 2y. If I differentiate this, I'll get 2x y squared z. That's the answer. I'm not focused on this because it doesn't have any s value. I'm differentiating with respect to x only. Remember, I'm not here to teach differentiation. Now, if I want to differentiate with respect to y, here, I'm only interested in the quantities that have y. Now, all these have y. So, differentiating this will give me 2x plus 3z plus, this will give me 2x squared y z. Differentiating with respect to z, that means I've not touched this, it doesn't have z. This will give me minus 3y plus x squared y squared. Now, for me to get the electric field at the point, it's just for me to plot these values, and that should be it. The formula is that E is equals to EXI plus EYJ plus EZK. Now, look at EXI here, the X, the Y. I've already solved this. So, putting them together, so this will give me, the E is minus, remember we have a minus bracket, 2y plus 2x y squared z Now, it's supposed to be plus here, but here is minus because of the formula. So this will give me minus. So this will give me minus. Remember, this is plus, but minus times plus should give you minus. So this is just bracket. Oh, remember, I'm supposed to include I. So this should be minus times plus will give you minus. So you have bracket 2x plus 3z plus 2x squared yz. Now remember your j. Now the same thing, minus times plus will give you minus. So it continues from here. Minus bracket 3y plus x squared y squared and then k. Now this is the electric potential. This is the answer. So that is all for this video. Let's go to part 3.